Higher homework exercise 1, question 1. Find the equation of the line which passes through the points 3, -2 and -1, 6. To find the equation of a straight line, two pieces of information we need are the gradient and the point which lies in the line. We have 2 points that lie in the line. We can choose one of these at random later on. At the moment we do not have the gradient, but we can find it using the formula m equals y2 minus y1 over x2 minus x1, and we can sub in values x1, y1, x2, y2. 6 subtract -2 over -1 subtract 3. 6 subtract -2 is 6 plus 2, which is 8, so we have 8 over -4, which simplifies to a value for the gradient, which is -2. Let's choose the point 3, -2 at random, and we'll have y minus b equals m bracket x minus a as our general form for the equation of the straight line. Subbing in values, y subtract -2 gives us y plus 2 equals -2 bracket x minus 3. Expand out the brackets, gives us y plus 2 is equal to -2x plus 6. Writing in the form ax plus by plus c equals 0 gives us 2x plus y minus 4 is equal to 0, and that's the equation of the straight line for question 1. Question 2. Find the equation of the line which passes through 4, 7 and which is parallel to the line y equals 2x plus 3. Parallel lines have gradients which are equal. We can see that the gradient here is m equals 2 for the line y equals 2x plus 3. It's already in the form y equals mx plus c, m is equal to 2. The gradient of the line that we're looking for is also equal to 2, since the lines are parallel. With the two pieces of information we need, we have the gradient and a point. Y minus b equals m bracket x minus a is our general form for the equation of the straight line. Sub in values gives us y minus 7 is equal to 2 bracket x minus 4. Expanding out gives us y minus 7 is equal to 2x minus 8. Writing in the form ax plus by plus c equals 0 gives us 2x minus y minus 1 equals 0, and that's the equation of the straight line for question 2. Question 3. Find the equation of the line which is perpendicular to the line y equals 4x minus 3 and which passes through the point 5, 2. Again, two pieces of information that we need for any straight line. We need a point and we need the gradient. We know that the gradient of the perpendicular line is 4, since it's already in the form y equals mx plus c. Our line is perpendicular. We know that the gradient of perpendicular lines multiply together to give -1. If we take m1 as being this gradient, 4, then the gradient that we're looking for, m2, multiplies together with 4 to give -1. Therefore the gradient that we are looking for is -1/4. With the two pieces of information we need, and we'll write down the general form for the equation of the straight line. Y minus b equals m bracket x minus a, and we have y minus 2 is equal to -1/4 bracket x minus 5. We can eliminate the fraction by multiplying through by 4. 4y minus 8 is equal to -1 bracket x minus 5. Expand out gives us 4y minus 8 is equal to -x plus 5. Writing in the form ax plus by plus c equals 0 gives us x plus 4y minus 13 is equal to 0, and that's the equation of the straight line for question 3. Question 4. Straight line makes an angle of 45 degrees with the positive direction of the x-axis and passes through the point -1, 4. What is the equation of this line? An angle of 45 degrees made with the positive direction of the x-axis should immediately make us think of m, the gradient, being equal to tan theta, where theta in this occasion is equal to 45 degrees and is the angle made with the positive direction of the x-axis. So m is equal to tan 45. Our knowledge of exact values tells us that m is equal to 1. With the gradient we have a point. Our general form for the equation of the straight line is our next line to write down. Y minus b equals m bracket x minus a. Sub in our values. Y minus 4 is equal to 1 bracket x, and subtract negative 1 gives us plus 1. Expand out. Y minus 4 is equal to x plus 1, writing in the form ax plus by plus c equals 0 gives us x minus y plus 5 is equal to 0, and that's the equation of the straight line for question 4. Question 5. Show that the points A, B and C are collinear, where A is the point negative 4, 3, B is negative 1, 1 and C is 2, negative 1. Collinearity means that points lie on the same straight line. Two pieces of information we need to show that points are collinear is that we have a common point and that the gradient of AB is equal to the gradient of BC. Let's first of all prove that the gradient of AB is equal to the gradient of BC. To find the gradient of AB, we first of all use our points, negative 4, 3 and negative 1, 1, and sub into our formula for the straight line y2 minus y1 over x2 minus x1. That is for the gradient. And we have 1 subtract 3 over negative 1 and subtract negative 4. 1 minus 3 gives us negative 2, and negative 1 subtract negative 4 is negative 1 plus 4, which is 3, and we have a value for the gradient of AB which is negative 2 over 3. MBC should also be equal to negative 2 over 3. Let's find out. So y2 minus y1 over x2 minus x1, and subbing in values this time, x1 y1, x2 y2, negative 1 and subtract 1 over 2 and subtract negative 1. We have negative 1 subtract 1 gives us negative 2. 2 subtract negative 1 is the same as 2 plus 1, which is 3, and we can see that the gradients are both equal and equal to negative 2 over 3. We also have a common point, which is B. We have a common point and we have equal gradients, therefore A, B and C are collinear, and that's our solution for question 5.